So, in this video we are going to learn how to find the equilibrium concentration from the equilibrium constant and initial concentration. Without any further ado, let's dive into it. What are the equilibrium concentration of all these gases if the initial concentration of nitrogen and acetylene were 3.5 molar and 2.5 molar respectively, in this balanced equation, this one here. It is given the equilibrium concentration 2.3 times 10 to minus 4. First, we can write equilibrium constant for the balanced equation. At this step, you have to be careful because solids and liquids are not included in equilibrium constant. In this case, we have all our compounds in gaseous state. And these concentrations here are all equilibrium concentrations. The easiest way to do this is by building a table like this. As you can see, you have only reactants, so the equilibrium is going to shift toward products. So it's going to shift to the right. At this point, be careful. I'm going to mark with X the change. So, in order to not make mistake, you have to consider the balanced equation. More precisely, the coefficients in the balanced equation are going to determine the quantity of the X in the table. So we have 1 here, and 2 here. X here, because are 2 here, 2x here. Equilibrium is shifting toward products, so you are consuming reactants. That's why we add the minus sign here, consumption of the reactants, minus here, and plus to the products because you are forming products in this case. Next step is to sum the initial step with the change step in order to find the equilibrium concentration. So these ones are the equilibrium concentrations. The final step is to place these equilibrium concentrations to the equilibrium constant that we are going to rewrite it again here. So for HCN you have 2x, this one here, square, 3.5 minus x for the nitrogen and 2.5 minus x for the acetylene. This is equal to the value of the equilibrium constant that exercise gave us at the beginning, 2.3 times 10 to minus 4. Let's solve it to find the x. At this point, we are going to solve the quadratic equation. This is the A, this is the B, and this is the C. Only one is meaningful in this type of problem. So you may have already guessed that x1 is the right value to take in the further calculations, because x2 is a negative value and we cannot have a negative concentration. It may happen that both x1 and x2 may be positive values. In that case, you are going to take the smallest value of the x. So the equilibrium concentrations are Thanks for watching, guys. See you in the next video. Peace.